Hello and welcome to a new video on IGCSE Physics Classified Paper 4. In this video, we shall be discussing force diagrams. Figure 1.1 shows a river in which the velocity of the flowing water is 0.85 meters per second, parallel to the river banks. A swimmer sets off from one bank. The velocity of the swimmer relative to the water is 1.2 meters per second at 45 to the river banks as shown. In the space below, draw a scale diagram to determine the resultant velocity of the swimmer relative to the river banks. The velocity is the resultant of the two velocities, shown on figure 1.1. Label this resultant on your diagram. So a suitable scale to use here would be something that you can draw with a ruler. So the ruler usually has 1 centimeter to 20 centimeters. So you need to be somewhere in the range between 1 and 20. Here your values are 1.2 and 0.85. So logically, it would be a good idea to multiply these values by 10. So you would have 8.5 and 12 because 0.85 is too detailed or too accurate to draw using the ruler. So therefore, we're going to construct a scale where 1 centimeter is equivalent to 0.1 meters per second. Or in other words, you can rewrite this as 1 meter per second is equivalent to 10 centimeters. So therefore, when we have 1.2 here, we multiply by 10, so we get 12 here. And when we have 0.85, we also multiply by 10, so we get 8.5 centimeters. So now you can draw 8.5 centimeters in this direction. And roughly at 45 degrees by eye, you should draw a line that is 12 centimeters. So it will be a bit longer than that, like this. That would be 12 centimeters. And then this would be 8.5 centimeters. And the resultant of the two forces is a force that begins at the tail of the first force and ends at the head of the second force. So this blue line would be the resultant force. Let's check the correct answer. So like we said, we would draw 8.5 centimeters for the horizontal line. And at 45 degrees, we have 12 centimeters. Now, you should be able to get this value using your ruler. So you should measure this value of the green line on your sheet using your ruler, and you should get the correct answer. However, if you want to figure it out mathematically, if you want to make sure that you have the correct answer, you can use the cosine rule. Since you have a triangle with two sides and an angle, so you can just use the cosine rule. R squared equals 12 squared plus 8.5 squared minus 2 times 12 times 8.5 cosine 45. This would get 72. Then you take the square root of 72 and you would get 8.5. Now, if you measure this with your ruler and you have an accurate drawing, it should give you 8.5 centimeters. However, if you're not sure, you can use the cosine rule. And anyway, after you're done, you have to use the same scale to go back to meters per second. So we said that 1 meter per second is equivalent to 10 centimeters. So we got 8.5 centimeters. We go back to 0.85 meters per second. You can cross multiply if you're confused as to how we got this value. Let's call it x. We can say 10x equals 1 times 8.5. So x would be 8.5 over 10, which would give you the 0.85. Another question says the boat in B is moving due west at a speed of 6.5 relative to the water. The water is moving south at 3.5. In the space below, draw a scale diagram to determine the size and direction of the resultant of these two velocities. State the scale used. So the quantities here are 6.5 and 3.5. These are already good quantities to use in your ruler, so you don't really need to create much of a conversion. All you have to do is say 1 centimeter is equivalent to 1 meter per second. So 6.5 would be 6.5, and 3.5 would be 3.5. And then you would draw the vectors based on the question. So you have a boat moving due west, so to the left, and this should be 6.5 centimeters. The water is moving south at 3.5. So we have here a vector 3.5 centimeters. Like we said before, the resultant begins at the tail of the first and ends at the head of the second. So the green line is the resultant. If we want to get the scale, if we want to get the size of the resultant, of course, we can measure using the ruler, but we can verify using the Pythagorean theorem. So x squared equals 3.5 squared plus 6.5 squared. And x would be the root of the answer. Of course, 3.5 squared plus 6.5 squared gives us 54.5. So we want to get the root of 54.5. And using your calculator, this would be 7.38. So x would be 7.38. If we want to get the direction, which is this angle here, we can use SOHCAHTOA from mathematics. So we have a triangle. This is 6.5, this is 3.5. We have angle theta here. So we can say tan theta equals 3.5 over 6.5, opposite over adjacent. And then you can get theta as tan inverse 3.5 over 6.5. And this would be 28.3 degrees. Of course, we know that this is below the negative x-axis because the green line is moving southwest. So if we have an x-axis and y-axis here, the direction is below the negative x-axis. So we can write here below the negative x-axis. And we can check the results. We would find that we have the same answers as the written solutions. Let's move on. Figure 4.1 shows a top view of a tourist vehicle in a game park and two elephants pushing against the vehicle. The two forces indicated are at right angles to each other. In the space below, draw a scale vector diagram to determine the magnitude of the resultant force. Label the two forces applied and the resultant and clearly state the scale you use. Now, the values given here are 4 kilonewtons and 6 kilonewtons. 4 and 6 are suitable values to use when you're measuring with a ruler. So you can simply state that 1 kilonewton corresponds to 1 centimeter. You don't need to convert anything here. So 4 kilonewtons would be 4 centimeters, and 6 would be 6 as well. Now let's draw the vectors. This would be 4 centimeters, and then this here would be 6 centimeters. And you want to label the two forces and the resultant. So let's draw the resultant again. It starts from the tail and goes to the head like this. This would be the resultant. And you can calculate it mathematically as root of 4 squared plus 6 squared. Just to verify your measured value. using the Pythagorean theorem, this would give us 7.2. Of course, after getting the resultant value in centimeters, you have to go back to kilonewtons, and we use a simple scale here, so there are no calculations required because 1 centimeter is equivalent to 1 kilonewton to begin with. Figure 2.1, not to scale, shows the view from above of the boat, now on a fast-flowing river. The boat accelerates. Two forces are shown acting on the boat. The resultant of these forces is at right angles to the river banks. The force from the river current is 80 kilonewtons. Determine the scale that has been used in the vector diagram. So we need to use the ruler here to measure the two forces. So this here is 4 centimeters. And if you measure the resultant force, you would get around 10.8 centimeters here. So in order to determine the scale, all we have to do is write down that the force from the river current is 80,000. So the actual force on the diagram is 4 centimeters. So 4 centimeters equals 80,000. We can simplify by dividing by 4. So 4 to 80 would be 1 to 20. So the scale would be 1 centimeter corresponds to 20 kilonewtons. In double I, we are told complete the vector diagram to determine the magnitude and the direction of the force from the engine. Measure the angle between the direction of the current and the force from the engine. So let's go back to the empty page and try to figure out how we can get the force from the engine. Now, we are given the resultant force here. So this is the resultant. The resultant should go from the tail of the first vector to the head of the second vector. So the head of the second vector should be somewhere here. Now, in order to get the second force, we should figure out that this force here would satisfy making the vertical line the resultant. How does that work? If we look at the two forces, the first force looks like this, the second force looks like this, and then the resultant goes from the tail of the first force to the head of the second force. So the green line would work as a correct result. So therefore, we look at the answer and we see that the resultant force looks like the green above. And since the resultant is supposed to be the force from the river plus the force from the engine, we can figure out that the force from the engine is the resultant minus the force of the river. Or in other words, the force of the engine is the resultant plus negative the force of the river. How would that help us? So if you didn't understand the mental way of drawing the resultant, you can figure out how to draw it in another way. So we have three forces. We have force from river, force from engine, and resultant. So this is F river, and this is resultant. And we should know that the resultant is the force from the river plus the force from the engine. Now we want to draw the force from the engine. So we want to isolate Fe. So let's say Fe equals the resultant minus the force from the river. How do we subtract vectors? Subtracting vectors is the same as adding the negative. So it's adding the negative of the resultant. Excuse me, you're adding the negative of Fr, which is the force of the river. So this is Fr. Fr goes to the left. So if I want to draw negative Fr, I would draw it to the right like this. Now I have negative Fr, and I want to add it to the resultant, which is R. So we can begin from the tail of the first and move on to the head of the second, and we would still get the correct force here. This would be equal to negative Fr plus the result. And that's what we want because Fe is the resultant minus Fr, or the force from the river. So therefore, the third force is negative Fr plus the result. Now, in order to get the magnitude and the direction, we can either measure by the ruler or use trigonometry. I've used trigonometry here to get the precise answers. So the magnitude would simply be the Pythagorean of these two quantities, and that gives us around 11.5 centimeters. And the angle would be tan inverse opposite over adjacent, and that gives us 69.72. However, we want the angle between the direction of the current and the force from the engine. So the force from the engine and the direction of the current actually have this angle between them here. So when we do tan inverse, we're actually getting the angle inside the triangle. And this is approximately 70. So to get the other angle, we would just do 180 minus 70, which is 110. So therefore, the angle between them is 110. As for the magnitude of the resultant, we have to reconvert it back using the scale we found in part I. So if 1 centimeter corresponds to 20 kilonewton, then 11.5 would correspond to x, and we would cross multiply. We would get 11.5 multiplied by 20,000 because it's kilonewtons. And the result would be 230,000 newtons, or 230 kilonewtons. This brings us to the end of our video. I hope this has been beneficial. Thank you for watching.